what I want to look at, well, all right, remember this week we've got, I'm going to finish out this today. We're going to start talking about the graphing review and all that kind of stuff today. And then we'll talk more of the, put everything else, laying the last second question stuff tomorrow. We probably could have tested tomorrow, but we'll be all right to push it. It's not a big, we have plenty of time. And then Wednesday we'll start the overall review chunk. We'll kind of go section by chapter. And then, no, we are testing on it. Oh, Wednesday's test. I'm sorry, Wednesday's test. I got home from school on Friday. My head was just so swollen out, my sinuses. I can't get rid of it. All weekend long I've been sitting just trying to get rid of it. Thanks, I try. Well, we're not. So when we get to a complex fraction, just like we had before, we treat it the exact same way. Don't worry about the equal to until you get to the very end. So let's not worry about the other stuff that you were doing. Mr. TJ. Mr. Oh, I had questions about how to do all this stuff, so you're doing other stuff in class instead of what you have questions about. See how that works? Put it away, man. So this one isn't as bad. This one, if you look at it, you only have to worry about the common denominator for the top part. And hopefully you guys realize that it's pretty quick. Your common denominator for the top is going to be x, and then x plus 1. Fraction on the left needs the x plus 1. Fraction on the right needs the x. You okay with that? And then I'm going to bring up the other part, so let's multiply by x plus 1 over 1. And all this is still going to equal 2. As you go through this, you'll notice that some of it works out rather cleanly. These two drop out. You have 1 over x times 20x plus 1 whole, which means that goes away. And then you have fraction equal fraction. Cross multiply, or remember when you have a variable in the denominator, remember sine of 34 is 6 over x. We just exchange O, change O. And technically it's cross multiply, right? So in essence, even though that was started out to look like it would be an awful thing, pretty quick, isn't it? Now, thinking about terms of finals and stuff like that, if this happens to be a style question that's multiple choice, are you going to math any of that? What are you going to do? Well, not just that, but can't you just use a calculator to figure that out? I'm thinking yes.
Okay.
Second semester will definitely be a calculator, not a calculator. But this one, I'm thinking that everything should be fine with it. I don't think you do. So if I go back to this, yes, sir. If I go back to the original equation there, do you guys know how to make complex fractions in your calculator? I will show you. We're going to hear a lot. You're going to hit the fraction bar a lot. Set, alpha y equals. Excuse me. And let's go ahead and let's type this into a y equals form and see how it works. If I'm not mistaken, it was 1 over x was the first fraction. Yes. We have 1 over x. And then it was subtract alpha y equals 1 over x plus 1. 1 over x plus 1. Now, what we can do here is we should be able to do an alpha y equals of the whole thing. I think it drops. Nuts. I had to go to the whole thing. Yeah. Yeah, I should be able to do that. Let me back out here. So if I go back into the very beginning, right in front of it, you guys know how to do an insert? You ever done that? Hit second insert where the delete is, put parentheses. And then put parentheses at the back. And now, if I hit alpha y equals, it'll make that entire thing unlimited. Pretty cool, huh? And that's okay, because it's been grouped, because it's going to go into a complex. And then the second part, if I hit alpha y equals, it's just because I only have one fraction for the denominator. If there was two fractions, I would do parentheses. Since there's just one, I don't need to. I just hit another alpha y equals, and I can create the denominator. The denominator was 1 over x plus 1. 1 over, I will show you. X, was it x plus 1? Okay. Now, in this case here, here's this. Thank you. So that fraction is, that complex fraction doesn't technically fit in that stream. But you're just asking, how do you get this part to equal 2? Well, you want to know where this graph intersects the number 2. A graph. And it'll graph this. And then, because it's a complex fraction, it's thinking. So at this point, can't I just hit intersect? You guys ever do that? Second, calculate, intersect. The second, calculate, and intersect is what it's going to look for where these two curves intersect. It's going to ask you a bunch of questions. First curve, yes. I think you just have to hit the right. So that way, you have to hit the turn to pick a curve. I just hit the right arrow, and all of a sudden my cursor's on the blue part. Are you okay with that? I hit enter. Second curve, it automatically jumps to the red one, and I hit enter. Guess. Orange juice. Oh, there it goes. There's your intersection. And 1/2. It intersects at 1/2. Now, here's the other thing. Your calculator will do the work for you, but if you had a multiple choice question, you got a complex fraction, aren't you just going to plug and chug? Wouldn't you just plug and chug all those answers? I mean, seriously. I mean, when you get to these, when you get to the idea of a nasty idea here, if I just want to know which value makes it equal to 2, and I have a whole bunch of answers, I could go and do the graph of it, check the intersection, or I can try and figure out what the points are by taking the answers, if that happens to be a multiple choice question. Now, what happens if, I think I have it open still. Do you think you could probably figure out the answer to this using the calculator? All right. Try it. Throw that in your calculator. Well, it's not literally throw it, but enter that into your calculator. Take a second to see. But the only thing you'll have to be careful of is that we don't type it in correctly. You should just be happy about the music. What'd you guys get? You guys get 4? I saw 4 with a lot of people. Anybody else not get that? Did you type something in incorrectly? Oh, yeah. Yes, sir. Did you have that out while you
That was what. Yeah.
Because now you have y equals this, y equals 3. Where do they hit each other? Not so bad. So, way back in the Wayback Machine, we did stuff that related to graphing. And, hey guys, I want to go over a few of these things with you about how you run. right, I would write this down a little bit different. I would say it's y equals negative 3x squared plus 0x plus 1. I'm sorry, plus 0. Reason why I'm going to write that out with all those extra parts to it to create the trinomial is because right away I remembered that since my degree in the numerator is 1 more than the degree in my denominator, I'm going to need to do some, or not, like long division to get the equation. So we go through the whole process again. X-intercept, 0 of the numerator. 0. Y-intercept, 0. The y-intercept is when x is 0. If x is 0, I get 0 in the numerator, and 0 plus 6, so it's just 0. Vertical asymptotes. Vertical asymptote is going to be at 0 of the denominator, negative 3. Okay. This is the case that has no horizontal asymptote because the degrees are smaller or larger than the numerator. There's no horizontal, but there is a slant. When we do slant asymptotes, this is the reason we use long division. What do you multiply 2 by to turn it into a negative 3? Negative 3 halves, right? Remember that trick? It's whatever the number is in the numerator, and then the number on the outside in the denominator. Now, I need to turn it into a negative, and I have to do an x squared. So, that means I'm going to write it as negative 3 over 2x. I distribute that across. Negative 3 over 2x times 2 is negative 3x squared. Negative 3 times 6 over 2 is negative 9. We get minus 9x. Then we subtract both parts. And I get 9x plus 0. What do you multiply a 2 by to turn it into a 9? 9x. Do I need to worry about anything else? No. Because I know that I don't care about remainders. I don't need to worry about any of that at all. I know that if I multiply 2 times 9 and then divide it by 2, I'm going to get 9. And I know it's going to work. I don't have to complete the rest of that out. And that gives me my slant asymptote in slope-intercept form. Like that. Not so bad. I hope. Does this vaguely remember any of this now? It's like, it kind of is there, it's partially-ish things. I'll post this page through here tonight. Or The graphs, what I want you guys to do for the graphs, is I want you guys to just label, like we did, x-intercept, y-intercept, horizontal, vertical asymptotes, slant asymptotes. When you go to the graph portion, all I need to know are those things. I don't need to know points. Okay? I want you to be able to identify where things are going to be located. Points then just come from plug and chug. I'm not worried about that. I want to know that you guys can find where everything is going to get placed. From there, the rest is easy. Remembering how to do that part is the excuse me. Give me 1 second. I'll pull this up so you guys can at least get a picture of it, because I don't think I have this actual page PDF.